Okay, objective 7, we were looking at solving one-sided limits graphically. So we have some notation here, one-sided limit notation. When you have a limit as x approaches c with this little minus sign, what that means is we are evaluating the limit of the function only from the left side of that value. So this is called the limit as x approaches c from the left. Versus the limit as x approaches c with this little positive sign, this evaluates the limit of the function only from the right side of c. So this is the limit as x approaches c from the right. Okay. We also have two additional pieces that we are throwing in. We've actually talked about them before. Removable discontinuities. Removable discontinuities are holes in the graph of f of x. So your holes are removable. Non-removable are your vertical asymptotes or your jumps. They're called jump discontinuity. And so we're going to be classifying those as well. Okay, so in number 1 here, we're going to walk through number 1, and then number 2, my recommendation would be to pause the video, give number 2 your best shot. That way you're getting that gauge, am I understanding the material or not? Right? So number 1, the limit as x approaches c, as x approaches 1 in this case, from the left of f of x. So x1 would be this line right here. So we are approaching that line there, and we are approaching it from the left, meaning starting on this side, we are going to be getting closer and closer and closer to my yellow line here, my 1, from this left-hand side, on the left of that yellow line, left of that 1. And so as we see ourselves getting closer and closer and closer to that yellow line, closer and closer to that 1, the question is, well, what y value, what f of x does it look like I'm going to be touching? And sometimes you do actually touch that point. Sometimes you just get very, very close and then there's a hole there or something like that. But it's what does the y value look like it should be? And so as I trace this graph, that y value, this graph is going down, 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 down forever alongside this x equals 1. And so the y value looks like it's going to be negative infinity because this graph is going down. Negative infinity, for the record, also is acceptable to put does not exist. And your reason would be because this is unbounded. Okay, approaching 1 from the right. So again, 1 is this yellow line here. Approaching 1 from the right, we're tracing this function. As we get closer and closer to that yellow line, what y value does it look like we should be? Okay, this function is going up as we get closer and closer to my yellow line, as we get closer and closer to 1. And so the y value that it looks like I'm going to be is infinity. You also could put does not exist because unbounded. You can always put does not exist because unbounded if your answer is infinity or negative infinity. Okay. 2. So C, we are finding our limit as x approaches 2 of our functions. Let me grab a different highlighter here. Okay. Approaching 2 in this case, well, 2 is right here. So we're approaching the pink line. Okay. In C, we are approaching 2 from the right of f of x. Okay. Well, as I get closer and closer and closer to 2, the question is, what y value does it look like I'm going to touch as I approach that pink line from the right? Well, as I approach that pink line, it looks like I'm going to touch y equals 1. Okay, approaching 2 from the left. As I trace this graph, this side, getting closer and closer and closer to my pink line, closer and closer and closer to 2 from the left, what y value does it look like I'm going to touch? It looks like I'm going to touch 1. Okay, my two-sided limit, the question is, well, are my left and my right, does it look like they're going to meet up? So as I trace from both sides here, does it look like they're going to meet up? And if so, where? In this case, yes, it does look like they're going to meet up. My two sides look like they're going to meet up at y equals 1. If it didn't look like they were going to meet up, we would put does not exist because does not agree. And then last one, x approaching infinity. So we're headed out towards x infinity, which is way off here to the right, right? X is going to infinity. And so as I trace this graph going way out here to the right, the question is, what y value does it look like I'm going to be? It looks like I'm going to end up hitting the x-axis, which is 0. Okay, removable discontinuities, those are holes. In this case, I have a removable discontinuity at x equals 2. We talked about up here, removable discontinuities. Non-removable discontinuities are my vertical asymptotes, or my jump. In this case, I have one vertical asymptote. It is at x equals 1. Okay, so my recommendation, pause the video, give number 2 a shot. That way you're kind of seeing how much of this am I understanding or not, and gives you information as to what you want to ask when you come into class. After you've gotten your answers or are stuck, restart the video so you can check. Okay, here we go. We are approaching 1. First of all, 1 is right here. Okay, approaching 1 from the left, which is this side. As I'm going up and up and up, closer and closer to 1 from the left, the y value it looks like it's going to be is infinity. Okay, approaching infinity. So infinity is way off here to the right. As I trace this graph going out as x goes to infinity, way off to the right, what y value does it look like it's going to touch? Well, it looks like it's going to touch y equals 1 here. As we go to negative infinity, well, negative infinity is way off here to the left. X going to negative infinity is way out here. And so if I trace the graph that's headed that way, that's this graph here, which is kind of coming down as we go left to negative infinity. So the question is, well, what y value does it look like I'm going to touch? It looks like I'm going to touch negative infinity. Both of these, because they are infinity, could be does not exist because unbounded. Okay, -1. So now we're approaching -1, which is right here. -1 from the left. As I'm getting closer and closer to -1 from the left side of my graph, the y value it looks like it's going to touch is -1. From the right, as I get closer and closer to -1 from the right, the y value it looks like it's going to touch is 1. In this case, as I trace from both sides, so this is neither left nor right, it doesn't have the little minus next to it or the little plus, so it's both sides. In this case, as I trace the graph from both sides, they don't meet up. They don't touch. And so this would be does not exist because does not agree. F of -1, f of x, what is f of x the same thing as? F of x is the same thing as y. My y coordinate at -1 is up here. This is my point. My point at -1 is 2. And then last but not least, we have -4. -4 is out here, this yellow line that we're drawing in. As I approach -4 from the right, so I'm over here tracing closer and closer and closer to -4 from the right. The question is, what y value does it look like I'm going to touch? It looks like I'm going to touch -2. Okay, removable discontinuities are my holes. I have no holes on this function, but I do have a vertical asymptote. A vertical asymptote here at 1. And I have a jump discontinuity. A jump is a non-removable discontinuity. The jump discontinuity is right here. We go from down here to up here, jump at x equals -1.